This is about transforming and altering a generic function, a function that comes without an equation, basically. So here you've got a picture of it and a table of it, and we're going to call it w of x. And you see its key points at -5 and 1, 0 and 5, and 4 and 0. And I'm going to ask you to manipulate it or use these new transformations to move it around. To do that, you have to understand what they do. And so let me kind of show you the breakdown of those ideas. Here we're going to do w of x minus 4. Now, you would have learned that that is the k value, the up and down motion. And so what we expect to the original points here at -5 and 1 and 0 and 5 and so on, that all of these values are going to drop by 4. So this one would be at -3, this one would be at 1, and this one would be at -4. And if you plot that 1, 2, 3, 4, here we would be at -5 and -3. Here, if you drop 4, you're at 0 and 1. And here, if you drop 4, you are here at 4 and -4. And if we graph that up, if we draw in the connecting lines, you'll notice that what's happened is everything's dropped down by 4. Now let's look at another of the relationships. This one's much more tricky. It's the right and left shift, and it's the opposite of what we would expect. So if you see here w in parentheses x minus 4, this is actually a motion to the right by 4. So everything in our graph is going to move to the right by 4. Now, what that means is actually the x values would just stay the same, because if you're moving the y values will stay the same. But the x is what's going to change this time because it's moving over 4 spots. So each of these would move 4 to the right, and we would get these spots. Let's see if that makes sense. -1 and 1, at 4 and 5, and at 8 and 0. Now if we connect these, we should find that this has moved everything to the right by 4. The shape should stay the same. Everything moves nicely. That's the guy. Let's move on to the last one. Now in this case, I'm not going to do all of the things that A can do. A can do a couple of things. I'm just going to go over one of them, and they all kind of work similarly here. A value is 2. The multiplier is a 2. What that means is everything that it is going to get dilated or expanded twice as much of what it once was from the x-axis. So if you look here, we are 1 away from the x-axis. So if you double that, we would be at 2. We didn't move it up 1, we doubled it. And here at 0 and 5, if you double that, you get 0 and 10. 5 doubled is 10. And this other one is 0 doubled, which is still 0. So it does a dilation of 2. You know what dilations do. They expand things. And so we see what's happened. The shape changed. It got expanded out quite a bit. Okay? Let me run you through a couple of the other kinds of questions that you'll see here that I quite enjoy. This one gives you a function, a parent. Here's the parent, and here it is. And I now have to guess or evaluate what has happened. The 3 is an expansion. There it is, E. So that takes care of that. Oh, the 2 is up 2. So let's find up 2. That's A. Good, we've taken care of that one. This one, we have in basically the brackets with the x. It's not +3 by itself, it's with the x. And so +3 is a right-left shift there, but it's left because it's the opposite of what we expect inside of the brackets. And so that is just good old-fashioned D. Let's show you another type. They're going to give you one graph, the parent, and a new graph. And I notice that this graph moved 5 this way and up 2, because it used to be sitting there. So if I want to move it 5 to the left, it would be in the brackets. Notice I put plus 5 because that's that way. And then I need to go up 2, and so that would be my equation, because I take my original parent and I adjust it 5 left and up 2. Here we're just writing down the new relationship, kind of like the last one, but from verbal here. So we want to go down and left. So if I want to go, let's see, left, I need to fix that. This is what I want to do, and then down. So I want to go left 1, so that's why it's in the brackets. And then this squared is on the outside. I did that wrong initially because it's got to be with the x all in the brackets, minus 5. And then this last one, reflected, that's a negative. And then right 3 would be x minus 3 up here in the exponent spot. Let's see, one more type of problem, and then you're ready to try them out. This is the same thing. I give you a function and then I move it and you explain what happened. It looks like I moved 5 to the right and 4 down. So 5 to the right looks like that, and 4 down looks like that. The original was just called g of x, and so in function notation I went 5 to the right and 4 down. Last one, they want you to take a function and adjust it. This would be 4 to the right, and this would be up 3. So I would move each point 1, 2, 3, 4, 1, 2, 3, and so on. 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, and then if I connect the dots, I will have adjusted my graph to this. All of these questions are just checking to see if you understand the transformations that are taking place and how they adapt and change the actual function. Enjoy this problem.